Hello, Julia Bell here. CCNA1, Chapter 3, Part 3, Moving Data. Here I have a quote about Metcalfe's law. The power of the network is proportional to the square of the number of users. Wow. Let's talk about data encapsulation, communicating the messages. Segmented messages have benefits. You have different conversations can be interleaved, sent on the same media. You increase the reliability of network communications. The disadvantage of breaking up or segmenting a message would be the increased level of complexity. Here we have two users, John and Mary. John's sending data. His has been broken up into small segments, ready to send. It goes out to the same shared media out there, and they take turns sending. So that's allowed different conversations to be interleaved, but yet they don't get confused because they have segment numbers and are put back together on the other end. Protocol data units, PDUs. We have data, we have segment, packet, frame, and bits. You saw this earlier, drawn on the OSI models. I'm going to talk about it in more detail here. Data is the general term used at the application layer. We call it data. And you pass this down the stack, you'll notice on the far right side. The next one, the segment. The segment is at the transport layer. It's the PDU at that layer, which has to do with reliability. The next one is a packet, which is at the internet layer. The frame is a network access layer, PDU. Bits are used when you're physically transporting the data over the medium. I think of ones and zeros of binary here, or bits. You need to learn to understand questions that could come up related to this. What layer of this OSI would you think a logical address would be encapsulated? That's going to be the packet, because here we think about IP address, logical address. That's right. Encapsulation. Again, that's the process of preparing it to go out on the wire. We start here with data. You end up with a TCP segment, an IP segment called a packet, and then down here it's called an Ethernet frame. And it prepares it to send out. At the other side, the client will receive it as Ethernet, then it strips that away to the IP, to this TCP, and then finally to data that the web client can receive. Here they're talking about decapsulation process, what I just mentioned of going the other way. Moving data in the network, accessing the local resources. Here you think about the physical layer, the ones and the zeros. It's timing and synchronization bits. Data link layer has your destination and source physical address. That's the one that's burned into the LAN card. The network is a destination source logical address. That is an IP address that was set up by the administrator or by your DHCP server. Transport, destination and source process numbers or ports. And the upper layers are encoded application data presentable to the end user, for instance. Now keep in mind that an IP packet has two addresses. You're going to have your source address and your destination. Source being who sent it, destination being where it's going. The source is the IP address of the sender. The destination is the IP address of the receiving device. The destination IP address is used by routers to forward a packet to its destination. Again, we talk about source IP address and destination in your network addresses. That's going to be the one that starts like 192. Whatever. It's a logical address that was assigned to it. Data link is going to be more a physical address that's burned into the LAN card determined by the manufacturer. Your source data link address is the physical address of the device that is sending the packet. Initially, this is the NIC that is the source of the IP packet. The destination data link address is the physical address of the network interface on either the next hop router, in other words, the closest router to get me out of my local network, or the network interface of the destination device. Finding the physical address and the network card manufacturer of yours. Here's how you would find that physical address. And I give you an example of my address. where I did start run. At that point I did command prompt CMD and then ipconfig/all. Physical address on my card was 00-23-14. Those first 3 octets are significant. Those tell me who the manufacturer of the card is. The second 3, where it begins with 8E, these are unique to the device. So what is the manufacturer of this hardware? If I go to this website, hwaddress.com, short for hardware, and paste in that physical address, it's going to bring it up, and mine is an Intel address. INTEL is who made mine. Here's some other examples. I'm only listing the first 3 octets just for ease of use. 00:11:0A is going to be made by Hewlett-Packard or HP. They've got many more addresses. This is just one that I picked at random. 00:23:6C is an example of an Apple ID. And again, they have many. Once they use everything in that series, notice they've got 3 sets of octets here. The numbers range from 0 through F as in Frank, because these are hexadecimal, which accounts for 0 through 15, which would be a total of 16 options per position. Addresses. Let's talk about addresses. I mentioned physical and logical earlier, and I want to kind of bring this slide into focus and help you get that. The network layer helps with path determination. It has a logical address. The logical address is determined by your administrator. It could be placed on there by DHCP, which hands them out, or the administrator could walk to every single device in the network and physically key in those numbers. 4 PCs, no problem. 4,000, sounds like a nightmare to me to walk to each and every one and touch them. That's network. When you look at on the other side, TCP IP model, that would fall at the internet layer. So keep in mind network, internet, very close. The closest in relation is transport. But when you're thinking about the logical address, let's talk about the physical address and the data link layer. The physical address is the MAC address that is burned in. I gave you an example of my address a moment ago, 00:11:0A, and then it had 3 more octets. These are 48-bit hex. These addresses were originally from Xerox Ethernet addressing scheme. It was their idea. It's burned into the network card so that when you get it, it's there. The first 3 octets tell who the manufacturer is. Communicating with device on the same network. Here we've got these 2 devices need to communicate. They're on the same network. The destination here would be your data link or your physical addresses. Here would be your network or your IP packet header with your logical addresses that were created by a human here and put on there. These are just fictional addresses, so keep that in mind. So it would have both of these in the header as it heads from this device to its destination of the server. The IP and the MAC address. Let's look at that. Need to understand and explain this one. ARP, A-R-P, is used to discover MAC addresses on any host on the local network. Local means, like in this case, we have 2 gentlemen here. They're attached to a switch, and so is our server. We're all here within the same geographic region. That would be local. It may learn the IP address through the use of DNS, or domain name server, or may know the destination IP address because the address is entered in the application manually. That's another option for why we know that address. But how does a host determine either the Ethernet MAC address of another device? Good question, because here we have 192. This first address is a logical address. It was designed by their administrator. This one is an example of a physical address. Again, burned into the device from the manufacturer. Same here, logical, and this one would be physical, burned into the LAN card of the device by the manufacturer. Now, most network applications rely on the logical address, which is this one, of the destination to identify the location of the communicating host. Where are you? How to find you. The data link MAC address is required to deliver the encapsulated packets inside the Ethernet frame across the network. So you got to have both. The animation on this in the curriculum, by the way, is very good. I highly recommend you look at that. But again, ARP is used to discover the MAC address of any host on a local network. And ARP is discovering what? The MAC address. You already have the IP or the logical, but you want the physical MAC address, and you use ARP to determine that. Default gateway. This, relating back to the labs you did in part 2, you're beginning to learn the power of networking. You notice I've got all the red arrows. All these three devices have one thing in common. They have knowledge of a common gateway. 192.168.1.1, 192.168.1.1, and the third one is exactly the same. What this is saying is I want to go to this address. It is our common gateway out of this local network. And when you look here at the router, right here at this point is where that address resides, 192.168.1.1. So that is a default gateway. You can say that it's thought of as a door to enter or leave this network, kind of a logical door. It is important that the address of the default gateway be configured on each host. Got that? On each host on the local network. If no default gateway address is configured in the host TCP/IP settings, or if the wrong gateway is specified, messages addressed to host on that same network or the remote cannot be delivered. So if I'm trying to get out of here and go to the web server on this side and I cannot identify that 192.168.1.1 is the gateway or the default gateway out of here, then I will never be able to make it over to this web server because I've got to know where the door exists. Communicating with your device and a remote network. Again, here's the user, here's the web server. This one is going to bounce through multiple routers before it reaches its destination. The user in this case is sending an HTTP request to a web server all the way over here on this network. During encapsulation for this request, I want to think about what information is added to the address field of a frame to indicate the destination. Do you hear the word? What is added to the frame to indicate the destination? The keyword here would be what is added to the frame to indicate. Frame would be the keyword to pick out of that sentence. Since the frame would be interested in a physical address, you're going to add the MAC address at this point. It starts up here with data, it comes down, the destination and source address are added in the IP or the network layer. The next thing that's added would be the MAC address. So the answer to that question is MAC is added at the frame layer, and that helps you to know how to get to the gateway. This concludes video 3.